is the exam. I know it's been ages since the exam, but I haven't sent them in to grade him because I wanted to have this meeting first before we, like if there's any troubles with any of the questions to find out now. So, questions about the questions. Questions about the answers. Answers about the questions. Yeah, permutations thereof. Oh, yeah.
I have a question about question 8.
Yes. Let me remind myself what question 8's on about. 6. Here we go.
Yeah.
Yeah, this is going to be fun. There would not be inflation bias if central banks did not care about inflation, governments did not have influence on the central bank did not have flexibility. Yes, and your question?
Yeah, so, like, I interpret it as, you know the way, like, expected inflation was identified without target, or the inflation bias is target inflation minus actual inflation.
Uh-huh.
Yeah, so if they didn't care about inflation, it means they don't have a target. That's why I put down A. So that's how,
You are correct. You are correct. Absolutely. We will include A as well. Yes. Yeah, that's perfectly reasonable interpretation. See, it was worth having the meeting. Aren't you glad I didn't get them all graded already? Well, it depends on whether you answered A or not, of course, whether you're glad or not. But I couldn't hear, sorry.
Would be worthwhile just going through the questions to say, is the answer wrong?
I mean, if people, I don't want to spend a lot of time on them if it's obvious to people, but if it's not obvious to people, I want to spend time, so in that sense, yeah. You know me, I can drone on for hours, and that not necessarily, yeah, you know. Yes? Sorry, I couldn't hear.
People have adaptive expectations. Is that not going to work against inflation?
So the inflation bias is about the long-run equilibrium. It's not about how we get there. And so with adaptive expectations, you would end up eventually in the same place. Right. It would take a while, though, right? Yes?
I have a question about question
4, yes. Yeah? Well, that's fun. The original Phillips curve stopped working because unemployment insurance, income taxes, German hyperinflation. Yes. The question.
I chose C because it's mostly the concern about the monetary policy change. When the US government standard doesn't, like the phrase itself doesn't necessarily mean that the monetary policy change to other things.
Yeah, so the trouble with that as an answer is just, there's a number of troubles, but primarily timing, right? Because the Phillips curve stopped working in the 1970s, whereas German hyperinflation was back in the 20s.
Yeah, but as what I associated with German hyperinflation is that after it stopped when Germans fixed the mark.
When what?
Like there was a mark after the first years. Germans, instead of that hyperinflation, went to the German mark, and all the other world also fixed the German.
Yeah, so that happened in the 40s, right after World War II. They went to their new German mark. Could people close the doors in the back? It's very hard to hear anybody. So they went to, in 1945, 1946, they went to their new German mark. And then for another 35 years, the Phillips curve was working just fine. So it doesn't, to me, seem like that's a connection.
Yeah, but like the fact that US left gold standard doesn't necessarily mean other countries like didn't because they did. Like they did, but they could still stay there.
Yeah. But of these, I do think D is the best answer. It's true that Germany wasn't on the gold standard, but it was pegging its currency to the US dollar as part of the Bretton Woods Agreement. And so de facto, it was on a messy gold standard, right? And she's not happy. She's not happy with me at all. No. So, I mean, I see what you mean, that they weren't literally on the gold standard. I do think of the four, that's the best answer because the others are so far out of time. Right? It all fell apart for all the countries in the 70s. The thing that happened in the 70s was all the major countries were now off the gold standard. Right? Whereas unemployment insurance has nothing really to do with it in any event, and it was gradually being increased worldwide. Income taxes were introduced usually for most countries early in the 20th century. And certainly by post-war, pretty much everyone had income taxes. And German hyperinflation was way back in the 20s. So this is really the only one that could be directly connected. So I think I see your problem, but I'm okay with the answer. Other questions about the exam? We can talk after if I'm not making sense. I might not be making sense. That happens.
Is there another MCQ?
There is no more MCQs. MCQs are over. It's the end of days. Yeah. Thank God. They're not my favorite, but yeah.
Can you explain question one, please?
Question one, yeah. Maybe I can. We will see. Okay, both theoretical economists and empirical economists frequently use natural logarithm rather than variable self. What is not a reason for this? Okay, we saw for us A is true, right? In theory, we had, for example, that if I can I draw? Let's see if I can draw. We had y, capital Y was equal to k to the alpha, L to the 1 minus alpha. And by taking natural logarithms, we could turn this into little y is equal to alpha little k plus 1 minus alpha little l. This was n. We didn't have l. We had n. Sorry. So we could do that conversion. We could make it into a linear equation. So A is a reason to use logarithms. C, differences in natural logarithms are related to the growth rates of variables. That's true. Like the natural logarithm of today's output minus the natural logarithm of yesterday's output gives you the growth rate between those two dates. Okay, this is a beautiful feature of natural logarithms, and that in particular is why we use the natural logarithm to the base e, rather than logarithm to the base 10, because logarithm to the base 10 doesn't give us the growth rate thing, whereas the natural logarithm, the ln, gives us the growth rate. Okay? Logarithms can be negative or positive even when the variable itself must be positive, which allows us to include potentially large negative shocks. And this is for the empirical guys. For us theoreticians, it's not an issue. But for the empirical guys, they really want to do, if we can do this. They really want to write y is equal to beta 1 plus beta 2x plus epsilon. Right? And they want to run that regression. And they say, well, epsilon is distributed normally, right? We have lots of reasons to think that. The law of large numbers, the central limit theorem says that lots of small shocks will add up to one big normally distributed shock, whatever the distribution of those small shocks are. So we want to say that's a normal variable, epsilon, But of course, a normal variable can be very large and negative. It could be negative 10 million. It can be, there's a chance that it's going to come out really negative, which means our y here might be really negative. But if we're thinking, for example, y is the unemployment rate, negative unemployment rate makes no sense whatsoever. But if y is the natural logarithm of the unemployment rate, then that can be negative, right? Because the logarithm looks like this. If this is, say, x, let me say y, and this is, my God, it's going to be a struggle. ln y, then if y is 1, the natural logarithm is 0. And then if y gets really small, the natural logarithm just gets infinitely small, like that. So it has this curved shape. So if we're looking at the natural log, an infinitely small or really, really small natural logarithm is still a positive y. And so by using the natural logarithm of variables, we don't have to worry about these negative shocks making our variable itself negative. Okay. Did that answer your question? Yeah. So our concern, well, for empirical people, I'm not an empirical person, I don't have this concern, but people that run regressions, a reasonable concern is that by specifying our regression this way, we're saying that y can be negative. And some things can naturally be negative, right? There's some things where negative makes sense. But a lot of economic variables, negative doesn't make sense. Negative unemployment rate doesn't make sense. Negative GDP doesn't make sense. Negative wages, well, actually, they do make sense. People pay to do jobs. But negative prices, you can kind of see it. But, lots of things don't make sense as negative variables. And that equation, that regression equation, is saying that if this shock is sufficiently negative, which it might be, then my variable will be negative. Okay? And that means that if we just had unemployment rate there, we'd clearly see a misspecification, right? We're saying that unemployment rate can be negative. We know that's rubbish. So right off the bat, we have a goofy equation. Now, maybe it's close enough for government work, right? Maybe the shocks would have to be so big that we're close enough to the right specification that we're okay, because we never really, truly, honestly believe these specifications are exact. And if we do believe that, we really need to see a psychiatrist because there's something wrong with our brain. It's clearly they can't literally be true. We're always just hoping that they're close enough that we're going to get meaningful answers out of it, right? So maybe we're fine. But if we take the natural logarithm of unemployment, then this isn't a problem at all. Right? Because if the natural logarithm is really negative, it still means that unemployment itself is positive. Okay. So that's the idea. Okay. And then using logarithm of variables means that any measurement errors in the variable are less likely to cause biases in the empirical specification. This is just untrue. Right? If we have measurement errors, which we always do, all kinds of unpleasant things happen in our regressions. And mostly people ignore it because it's too much of a nightmarish hellscape to try to deal with it. Sometimes people try to deal with measurement errors in a proper way, which is quite difficult to do. But just taking natural logarithms doesn't solve that problem. That problem's still with us. Okay. Other questions about the exam? Okay. So there's one question I'm changing the answer to. All right, let's see if that can think about itself for a minute. and try my best to remember where we were at. Here we go. Okay, so we're almost done. Yeah, we'll have to make do. We'll see if this. We're almost done with Fisher-Gray. We have one more model to do, one more thing for it to teach us, and that will lead us into how central banks actually do policy these days. Okay, all based on this. And the story we're telling here is a different story. So up till now, we've told a story about wage setters or other input price setters. They have to make these short-term contracts. They're going to be stuck with it for a while. And they have to, when they're setting their prices, setting their wages, they have to take into account expected price growth because they need to be compensated for that, or that's a cost to them, right? And so that gave us our thing. They might predict wrong, and everything we've learned so far is based on that. But that isn't actually how we started this whole expectation thing. We started it last year was talk about investment. Right? If you're thinking about investment, you're wondering about business conditions next year. If business conditions are expected to be good next year, maybe you should invest. Right? But if business conditions are going to be bad, maybe you shouldn't invest. And we also talked a lot about consumer sentiment. Right? If I thought that I'm going to lose my job, I would start saving now so that I had a nest egg, and therefore consumption would go down. So consumption and investment are very likely to be functions of how good we expect the future to be. Okay? And so we are going to incorporate that in our model. So we have our same model we always had, or a version of it. Let's see if we can. Okay. Aha, black. I'm so happy I have black. PT is equal to MT minus YT minus Y bar plus VT. VT is equal to epsilon T. MT is equal to, what do we want to do with that? Equals minus gamma epsilon T minus 1. So this is a story. This is the same story we had before. And here we've got the central bank can't react instantly, and it can only react to things after a lag, which is realistic. It takes time to learn what's going on. It takes time for money supply to actually affect anything. And so there's a lag, right? They can't react instantly. And importantly here, the crucial equation is going to be our output equation, which is going to be YT minus Y bar, very sad Y bar, is equal to theta 1 PT minus PT given T minus 1. This is like what we had before. This is people predicting their wages, predicting prices for their wages. But we're going to add in a new bit, theta 2 PT plus 1 minus PT. And this is the investment bit. Or consumption bit. This is, we're looking forward. If prices are going up, we're going to invest more now, right? Because our product, it costs very little to buy a factory now. In the future, our product will sell for a lot. So it's worth investing now. Or I'm thinking as a consumer, prices are going up. Therefore, maybe I should buy my car now rather than wait. Maybe I should buy a refrigerator now rather than wait because prices will be higher. So if I think prices are going to grow, I'm going to buy stuff now. And this is a different motivation than what we had before. Okay. So how do we solve this, and what are we hoping to learn? We're going to learn that there's another reason why monetary policy can affect output. That's where we're going. And we solve this in the same way we've been solving it up till now. That is, we're saying the big problem with this is that we don't know what these price prediction errors are. We don't know the expectation. This is not pt plus 1, pt plus 1 given t information. Right? This is an expectation of the future. Right? Hopefully that makes more sense now. I don't know, people are asleep. They don't know. Not everybody. Not everyone's asleep. Mostly if people are asleep. The snores. Okay. That's the big problem. So we need to know how prices are determined in this model, right? How are prices determined? And we've got two main things that are being determined in this model. We have output and we've got prices. And so we want to get rid of output, combine our equations to get rid of output, and just look at the price process. So I am going to take this equation and plug it into here. Okay. So I'm going to get PT is equal to, and I'll plug the other ones in too, minus gamma ET minus 1. That's the money supply. What the heck? Fine. I give up. I totally give up. Computers hate me. Do they hate everyone, or is it just me? We will get rid of the computer, and we go back to paper like schmucks. Losers. We're going back to paper like losers. The trouble, it turns out, is my computer has a faulty keyboard. It keeps triggering things. Switch to another computer, that's not happy either. It's just slow of brain, like the rest of us. Okay. So we're going to get our equation, which is PT is equal to minus gamma ET minus 1 plus ET, which is the velocity, and then minus theta 1 PT minus PT given T minus 1 minus theta 2 PT plus 1 given T minus PT. And that's our star. That's the process that actually determines prices in this model. And what we want to do is we want to use this to find what these expectations terms are. What last period's expectations of today's prices are, and what today's expectations of tomorrow's prices are. The first one determines wages that were set a period ago. The second one determines how much we invest or consume this period. Okay. So we need to make a guess. We're going to do the same thing that we did before. We're going to guess and verify. And what is our guess going to be? Well, it can't be based on future things, because future things clearly aren't. We're looking for a reduced form. What are prices given today's circumstances and the past? That future bit's going to be a bit odd, but we can't be putting in ET plus 1. Like, prices can't depend on tomorrow's shock. That's just goofy. So we really only have today's and yesterday's shock. And so we can do two things. We can think, what should be in there? It should be everything that's in the original equation. And we should also be thinking it should be everything that people know at the time they're making their expectations. And clearly, in terms of this one, all they know is today and the past. They don't know the future. And in terms of this one, they know ET minus 1. And so we're going to guess PT is equal to R1. Let me make the guess the same as my notes, because that would be happy. ET plus R2 ET minus 1. Right? That's everything that they know at the time that they're making their price prediction, and everything that happened since. Okay? And it's also everything that's in this equation. So it matches up. Okay? One of the things that you'll see on the homework for this week's tutorials is that these two stories don't match up. And one of the things I want you to do is to think about what to do then and what to guess then. Okay? Now don't sweat it too much, because if you guess wrong, the math will tell you in no time. Like, you don't need to spend hours thinking about it. You give yourself 5 minutes to think about it, make a guess, see if it's right, and then you'll have learned something. Okay. So we're looking for these price prediction errors. We're wondering what this is, and we're wondering what that is. So the easiest one is the one that we've done before, that one. So let's start with that. PT given t minus 1. Just taking the expectations of this equation, PT given t minus 1, that's the left-hand side, has to equal to R1 ET given t minus 1 plus R2 ET minus 1 given t minus 1. We're trying to predict tomorrow's shock. We're trying to predict today's shock. But of course, we know today's shock. And this has mean 0. Right? We don't know what it is yet, but it's going to be random. Sometimes it's going to be high, sometimes it's going to be low. On average, it's going to be 0. So this whole thing is equal to R2 ET minus 1, which means PT minus PT given t minus 1, this term here is equal to R1 ET plus R2 ET minus 1 minus R2 ET minus 1. Right? This is just the guess itself, PT, and this is PT given t minus 1, which we just found there. And so that whole thing is R1 ET, if the guess is correct. And that's not a shock, because why are they going to make mistakes, right? This is the mistake they make in predicting prices. Why are they going to make mistakes? They're not going to make mistakes based on things they know. They're going to make mistakes based on things that they don't yet know, that came up in the meantime. So they're going to make mistakes based on time t shock, not t shock, but shocks in time t. That's so much better in Ireland. They won't make mistakes based on shocks in t minus 1, because they already knew those. Okay. That's if our guess is correct, of course. Now, if we can get all this in, yes. Let's sneak that up there. We're going to look for this term, PT plus 1 given t, which is something new that we haven't had before. And recall that our guess is PT is equal to R1 ET plus R2 ET minus 1. Okay? Well, we're looking for our guess today about tomorrow's price. So we don't have PT plus 1 in here at all. So it was easy enough to take expectations here, because we already had a guess for what PT was. But we don't have a guess for what PT plus 1 is, except that if we think this is the process that governs prices, if our guess is correct, it governs prices every time, an equation like that is going to be true in time t. An equation like that is also going to be true in time t plus 1. So 1 period later, PT plus 1 is going to be equal to R1 ET plus 1 plus R2 ET. Just putting the whole thing forward 1 period. Right? Because if it's true now, a similar process is going to govern prices a period from now. Just putting it forward 1 period. And then once we have that, we have our PT plus 1. Now we just need to take expectations of it in time t. So this is how prices, if our guess is correct, this is how prices will actually be determined in period t plus 1. And now we're wondering, what do we expect of that 1 period earlier? right, in time t. Okay. So we take expectations of both sides. That's pt plus 1 given time t information is equal to r1 et plus 1 given t information plus r2 et given t information. Just taking the expectations of both sides given the information that we have at time t. Okay. Now, this bit is known at time t. It's just look out the window, find out what the shock does. But this bit is not, right? Because this hasn't happened yet. We're at time t. We're thinking about what the shock is going to be in time t plus 1. Hasn't happened yet. We don't know what it is. Maybe it's going to be high. Maybe it's going to be low. On average, it's going to be 0. So this is unknown, but it has mean 0. So this whole thing is just R2 ET. So we're looking for this term. So pt plus 1 given time t information minus pt. Our expected growth in the price level is going to be equal to R2 ET. That's the pt plus 1 given t information that we just found, minus pt itself, which is just our guess, which is R1 ET plus R2 ET minus 1. So this whole thing is equal to R2 minus R1 ET minus R2 ET minus 1. Which is a whole lot messier than what we're used to, is it not? But there it is. That's what our thing looks like if our guess is correct. Okay. So if our guess is correct, we have our two price prediction errors. Now we just need to check and see that the guess actually is correct. So we need to take these price prediction errors, plug them into our original equation, star the actual price process, and see whether that looks like our guess. Right? And if we can find parameters such that they're the same, then the guess is correct. And if we can't, guess was wrong. So I'm going back to, call this 1, call this 2, so I scan them in the right order. Now I'll call this page 3. I'm going back to star, and I'm plugging in these price prediction errors that we just found. Okay, so that's so that gives me PT is equal to minus gamma ET minus 1 plus ET minus theta 1. Our price prediction error, that one, which we found to be, if I can, yeah, it's going to be here. We found it to be R1 ET. So that's just R1 ET minus theta 2. And this price prediction error we found to be this unpleasant thing. All right, so we'll just plug that in. R2 minus R1 ET minus R2 ET minus 1, like so. Okay. Now we've got a thing. This is, if our guess is correct, that would be true, but we don't yet know that our guess is correct. Now we have to find whether there's any R1s or R2s that make our guess look like, make this look like our guess, right? And so what I'm going to do is I'm going to combine all the ET terms, and I'm going to combine all the ET minus 1 terms. So ET terms, let me see. ET terms, I've got one ET there. I've got this many ETs there, and I got that many ETs there. So in terms of all this times ET, I've got one of them here. That's 1. I've got minus theta 1, R1 of them there. And I got minus theta 2, R2 minus R1 of them there. Okay? That's all my ET terms. And then my ET minus 1 terms, I've got one of them there. I've got one of them there. So minus gamma, so minus gamma there, minus 1. And then minus, this is plus. Now, let me do this plus and put this minus gamma. I got confused. So this is going to be plus theta 2 R2, right? Minus times minus is plus. So combining these terms, PT is equal to 1 plus theta 2. Now, yeah. Hey, it's a bit of a mess, so I'm going to leave it that way. We could simplify it in different ways, but that's all our terms multiplied by ET, all our terms multiplied by ET minus 1. I'm not going to simplify it further because just looking at it, I don't know which way of simplifying makes things simplest. Do I combine all the R1 terms together? Do I leave, like, I don't know. So that's our thing. This is if our guess is correct, and our guess was PT is equal to R1 ET plus R2 ET minus 1. Okay. Now, things are considerably messier than we're used to, right? Yeah, it's unpleasant. And you can see why I didn't start the whole thing with this, because this is a bit of a mess. What makes it a bit of a mess is that we need to find an R1 so that R1 is equal to this. And of course, R1 is in there like we're used to, but also R2 is in there like we're not used to. And so that's a bit of a trouble. Now this is less trouble. R2 has to be equal to that, and it's just R2 here, R2 there. So we can probably solve for R2, which is where we're going to start. But in general, we are just solving these two equations, looking for an R1 and an R2 that solve it. So we've got two equations, we've got two unknowns. We can do this. We can do this thing, right? And so we can get these. Well, we're not solving them quite like that. We're solving them like this. Sorry, that's wrong. Scratch that. That was goofy. We're solving these two equations. We're solving R2 is equal to minus gamma plus theta 2 R2. That's one of our equations. This is equal to that. And R1 is equal to 1 minus theta 1, R1 minus theta 2, R2 minus R1. Okay, these are our two equations. We've got these two equations. We've got two things we don't know, R1 and R2. We're going to use our algebra skills to find these things. I remember I had algebra skills. Yes, you did. You have algebra skills. You can do this. Now, clearly we want to start with the easiest bit, right? So far, we've been able to solve those equations separately, and that made our life easy. Now we cannot solve them separately because we got, unfortunately, both R1 and R2 floating around in here. So that's sad and really bad for us. But no worries, it's two equations, two unknowns. We can solve this, right? And obviously, the easiest way to start is with this one, because it's just R2 on both sides. I just need to solve for R2. Okay. Yeah. Happy days, let's solve for R2. So I'm going to bring all the R2s. So I got minus theta 2 R2 plus R2 is equal to minus gamma, like so. R2 times 1 minus theta 2 equals minus gamma. R2 is equal to minus gamma over 1 minus theta 2. And always fun, always fun. Does it match the notes? One wonders. Oh, yes, one does. Yes. Yes, it does. It matches the notes. And the notes write it nicer, of course, equals gamma over theta 2 minus 1, because negatives are pain and nobody wants negative things. Nobody wants fractions, but we're stuck with fractions. Nobody wants negative things, so make them positive. Right? Okay. Now, we need to find R1. And so I'm going to rewrite this one as R1 is equal to 1 minus theta 1 R1 minus theta 2 R2 plus theta 2 R1. Combining all the R1 terms, on the left-hand side, I got one of them to start from here, plus theta 1 minus theta 2. R1 is equal to minus theta 2 R2. Right? Yeah, we'll assume. Like if I make an algebra mistake, please stop me. Okay. And assuming, I should have said this, 1 plus theta 1 minus theta 2 is not equal to 0, and here we assumed it's not equal to 0. So we can do the division, right? We get R1 is equal to minus theta 2 R2 divided by 1 plus theta 1 minus theta 2. We do that division if it's not equal to 0. And then I can plug in R2, and I get R1 is equal to minus theta 2 gamma over theta 2 minus 1, 1 plus theta 1 minus theta 2. Happy days. Right? Yes, absolutely.
Also, if theta 2 equals 0 there on the left-hand side, that be theta 2 can't equal to 1.
Can't equal to 1. So true. Thank you. So true. So true. So we can do the division. Okay. There you go. We'll just assume that. Like if we were doing a PhD thesis, we'd worry about that forever. But we're not. So we'll just continue. Yeah.
Equals to 1. So you see the R1 equals 1, take away everything. So the 1 that was there is supposed to be on the right-hand side.
I couldn't follow. So
1 take away theta 2 R2.
I
Higher up, so it's supposed to be 1 plus theta 1 take away theta 2 R1. 1 equals 1 take away theta 2 R2.
did I screw this up?
2 1 take away theta 1 R1.
1 take away theta 1 R1.
Yeah, so where did the 1 go?
Where did the 1 go? So true. Yeah. Absolutely. That plausible? Yeah, that's plausible. And that actually matches the note where the other one not so much. Yeah. So there it is, an unpleasant Mankey thing, which we're not going to study and obsess over for long periods of time. Just to note, though, that our guess was correct, right? We have solved for R1 and R2 such that these things, and I got to let you go, so I will let you go, and we'll talk about what this means for output next time, and that will be the end of Fisher-Gray.